Hi everyone, this is Mrs. Pagan. Welcome to another day of learning mathematics. In today's lesson, we're going to be solving linear systems by elimination. So let's go ahead and get started. Now, so far the last couple days, we've done couple methods for solving systems. And one of them was the first one, which is graphing. And the second one was yesterday, which was substitution. And today we're going into our third method, which is elimination. Alright, so these are different ways of solving the same types of problems. And yes, we are going to be specifying which method so that we can know, do you understand all these different methods? Alright, let's go ahead and get started. Okay. So the first way is, it says use the elimination method. Sometimes this is known as linear combination. Just in case I say it that way, you know what it is. So to solve the system of equations. So basically what we do is we eliminate a variable and we add these two together. And notice it's 6x minus 6x, that cancels. So then we add 2 plus 6 and we get 8y equals, and we add 2 minus negative 18 and we get negative 16. We divide by 8 and we get y equals negative 2, and then we solve for x. Now I go into one of the equations, so I know the first equation we have is 6x plus 2y equals 2, and what I'm going to do is substitute in the negative 2 I got for y in there. So we get 6x equals, plus, not equals, 2 times negative 2 equals 2. We get 6x, and then we multiply these, we get minus 4 equals 2. We add the 6. Why is that's not a 6? Hold on. I must be in love. I'm making all these mistakes. Alright, so we add the 4, and we get 6x equals 6, divide by 6, and x equals 1. Now, a lot of people are like, yay, we're done! But you have one more thing you still have to do. You have to write it as a point, and the point that we're talking about is 1 comma negative 2. So here it is. That's our final solution. Alright, so now we kind of just jumped right into elimination, but I'm going to talk more in detail about what we're doing. So the idea of elimination is to eliminate one of the variables. So in this first one, we eliminated the x's because 6x minus 6x is 0. So they kind of eliminate themselves, which is awesome. Alright, let's do the same concept here. So we look at it, we say 6x and x, they don't eliminate themselves, but positive y and negative y, they eliminate themselves. That's awesome. So when I add these, I get 3x plus 1x is 4x. Positive y and negative y cancel each other out, equals 1 plus 4 is, 3 is 4. Divide by 4 on both sides, and x equals 1. So now we have one of our variables already solved for. Then we go into one of our equations, and I'm going to just go ahead with the first one. It's 3x plus y equals 1. And I'm going to input my 1 that I found here for x plus y equals 1. 3 times 1 is 3. Plus y equals 1. Let's subtract that 3 to the other side of the equal sign. We get y equals 1 minus 3, which is, help me out, negative 2, yes, thank you. So negative 2, that's our answer. Now a lot of people once again are going to be saying, oh, I'm done, but we're really not done until we write 1 comma negative 2, and that's our answer. There's no reason why these are all 1 comma negative 2. That was just craziness. It was just luck. Alright, let's go into example number 3. Example number 3 is a little different because it's difficult. 6x and 5x, they don't cancel, and 4y and 2y, they don't cancel. So what I have to do sometimes is multiply one of these equations by a certain number. So for example, if I multiply this second one by negative 2, right, multiply by negative 2, then I'm going to end up getting a negative 4y, which would then cancel out with a positive 4y. So here's what that looks like. The first one will stay the same, 6x plus 4y equals 16. So I just rewrote this again. And then negative 2 times 5x is negative 10x. Negative 2 times 2y is negative 4y. Do you see how? Woohoo! So nice! Equals negative 2 times 12 is negative 24. These y's cancel, which is what we were hoping one of them to cancel at least. 6 minus 10 is negative 4x equals. And then 16 minus 24 is negative 8. Divide by negative 4, and x equals 2. Woohoo! Now, we still have to solve for y, so I'm going to just plug it into the first one. 6x plus 4y equals 16. I could have picked any one. I just tend to always go with the first one, unless the other one is really, really simple. 6 times 2 plus 4y equals 16. We get 12 plus 4y equals 16. Subtract the 12. These cancel. 4y equals 4. Divide by 4. And y equals 1. Now, we do have to write this as a point, so here it is. 2 comma 1. Right? X is 2, y is 1. That's our solution. Awesome. Well done. All right. Let's kind of talk. So, well, how do we eliminate? Well, it says there's certain steps that we're taking, and sometimes it's nice to write these steps, so we're going to go ahead and write them. It says first we have to line the equations with like terms. So make sure, for example, in this one, x's are lined up, y's are lined up, equal signs are lined up, and the numbers are lined up. Alright, so if necessary, we're going to have to multiply the equation by numbers to get opposite coefficients. So for example, this one is not necessary because they cancel. But in this one, you might have to multiply the top by 3 in order for it to cancel. Then we're going to go ahead and add the two equations, and we're going to solve for the remaining variable. Once we have that, then we're going to use the solution from step 2, and you are going to put it into the original equation to solve for the other variable. Alright, so let's kind of do those again. Here's my first equation. Here's my second equation. And you can tell right away that things are going to cancel, so we don't have to multiply by anything. So we're going to just go into addition. 4x plus 6x is 10x. And negative y and positive y cancel each other out. It equals negative 11 minus 9, or add them up, we get negative 20, divided by 10, and x equals negative 2. Woo! Now, we still have to solve for y, so we'll use the first equation, 4x minus y equals negative 11, to solve for it, where x is negative 2. 4 times negative 2 is negative 8, minus y equals negative 11. Add the 8. Negative y equals negative 3, and divide by negative 1. That's a 1 right there. Y equals 3. Woo! Now the final answer is written as a point, negative 2 comma 3, and yes, if we don't do that, it is wrong. So graphically, it looks like this. And that would be at negative 2 comma 3. Cool. Alright, let's look at example number 5. We're going to go ahead and do the same thing, but in this case, I can't just cancel or add any of them to cancel a variable, so I'm going to multiply the top one by the number 3. Because if I multiply 3 times negative x, I get negative 3x, which then will cancel that out. Alright, I'm going to rewrite them again. 3 times negative x is negative 3x. 3 times y is positive 3y. Negative 2 times 3 equals negative 6. And I'm going to go ahead and rewrite what I see in the second equation, because I'm not changing that. Now, once we add them, negative 3x and 3x cancel out. That's 0. Oh, wait. So does positive 3y and negative 3y. That's 0 as well. Equals negative 1, 5. Well, that's not true. 0 doesn't equal negative 1. What? Alright. Well, if you ever run into a situation like that, that means that the equations have a no solution. Meaning that if I were to graph them, these lines would be what kind of lines? Great job! Yes, they would be parallel lines. So, because it's not a true solution, or a true expression, I guess you can say, it's not equal to anything, so no solution. Alright, let's look at example number 6. Example number 6, we're going to go ahead and see if anything cancels. But there's a problem with number 6 because it's x, y equal sign number, then it's x number equal sign y. So I need to put it into order first. So I'm going to go ahead and move the y to the other side. And I'm going to get 4x minus 16 minus y equals 0. Then I'm going to add the 16 to the other side. So I had to do some work beforehand. 4x minus y equals 16. Alright, so this is my second equation. I just kind of rechanged it. I'm going to rewrite them all. So here's what that looks like. Just kind of do that. 8x minus 2y equals 32 is my first equation. My second equation is 4x, I'm writing this, minus y equals 16. Alright, I can't cancel anything right away, but what I can do is multiply the bottom one by negative 2, because 4 times negative 2 is negative 8x, which then would cancel that out. So I'm going to write 8x minus 2y, which is the first equation again. Negative 2 times 4x is negative 8x. Negative 2 times negative y is positive 2y. And negative 2 times 16 is negative 32. We add them up, and here's what we get. 8x minus 8x cancels out. Negative 2y plus 2y cancels out. You're left with 0 on the left side, which equals 32 minus 32, which is 0. Does 0 equal 0? Yes. So that means that this has infinitely many solutions. Well, what does that mean? Graphically. Well, graphically, that means that if I were to graph this line, these two lines, it would look like this. Where's the other line? Hold on, I'm graphing it. Yep, you're right. They would be on top of each other. So it would look like one line, but it's really two lines. Alright. Well, I just want to say you did a great job. I want you to try example number 7, please, and we'll go over that first thing as soon as you come into class. Give yourself a hand because you did an excellent job. Can't wait to see you in class.